Today we're going to be working on finding the radian measure depending on a diagram. I'm going to be doing all of the odd ones. If you want to pause the video and get started, I'll show the answer key here in a moment. So like I said, I'll do the odd ones. If you want to try the even ones, here is the answer key down below. So when it comes to the diagram, notice that there's not much context other than the direction of the angle. Now keep in mind, if it is going counterclockwise, so if it's going counterclockwise, it's going to be a positive angle, and the reverse is true. If it is going clockwise, it's a negative angle. So here we have a counterclockwise motion. So in our case, we will be dealing with a positive angle. So our angle right here, we want to figure out how much of this do we have. Now we can do it in a couple different ways. One way is to determine using a reference angle. A reference angle is always from, notice down here, this is your terminal ray here. It's always from your terminal ray to the x-axis, no matter where it lands. So for example, we don't need to memorize the whole unit circle. We instead just need to remember your first quadrant. So if I am to match this particular terminal ray with something that I know from the first quadrant, it would be listed right here. And you can tell that this angle here, so this theta is going to match this one here. So notice that it is going to be it's going to be cutting your 90-degree angle here in half, meaning that if I were to do the same in my first quadrant, when I cut this angle in half, that I now have a 45-degree angle, 45 degrees or pi over 4. So this amount here is pi over 4, and that matches over here. So that just means that pi over 4, right, is this reference angle. So if it's pi over 4 and it's cutting a 90-degree in half, that also means that this portion here is, again, 45 degrees or pi over 4. So if we take what we know about this angle here, oops, let me re-highlight that. So notice that we're traveling around the unit circle, and I haven't quite fully made it this whole rotation. And actually, I highlighted that incorrectly. Uh-oh. Well, let me try that again. There, I'll highlight it down here. So notice that we haven't traveled a full rotation about the unit circle, but if we did travel a whole rotation, we would have finished at 2 pi. Now, how much of it did we not complete? Well, we just left off this little pi over 4 amount. So what we can do is we take this this 2 pi, your full rotation, and we subtract the little sliver that we did not complete. In our case, that little sliver was by pi over 4. So this would be 8 pi over 4 minus pi over 4. So that just means that everything in blue here is 7 pi over 4. So for me, I don't need to memorize this whole unit circle. If I can use what we call a reference angle, I'm referring to my first quadrant, what I know about my first quadrant, and how to apply it to the remainder of our chapter, of our unit circle. So now I'm going to try number 3. So you'll see number 3 here. We are going in the clockwise motion, which means that we do have a negative angle. So I'm going to just automatically put a negative sign here so I don't forget in the future. So this is your theta. And what we can do is, if I'm highlighting this whole thing right here, So again, we're traveling all over this unit circle, but we haven't traveled a full complete revolution. So if we want to, we can take this pi over 2 and actually if we're gonna go over to the negative side, it should be well, pi over 2, right? If we haven't traveled this whole unit circle quite yet, we are missing by how much? Well, we're missing by this 90 degrees. So this in our first quadrant is 90 degrees or pi over 2. So when I subtract this pi over 2, this should be about 3 pi over 2. Now keep in mind we are talking about a negative angle going the counterclockwise or the clockwise motion. So we really have a negative 3 pi over 2. Now, if we were to do it in a different way, let's say I don't subtract that amount, right? But let's just say, well, at least I understand that if this whole circle is 2 pi, if I at least travel half my circle, so this half right here, well, half of 2 pi is just pi, and we're going in the negative motion, so we have a negative pi. And then I just need to figure out, well, by how much is this angle? Now to go from one terminal or one edge to another, right? This is a full 90 degrees. So this is a full pi over 2. And again, going in the clockwise motion is a negative pi over 2. So I can subtract these two together. So negative 2 pi over 2 minus pi over 2 will give us that negative 3 pi over 2. So let's try 5 and 7. So you'll notice that this this circular motion is telling us that we've actually gone over the unit circle. So we've actually rotated over by over a certain amount. So if we start here at 0, notice that we have now traveled a whole pi or 2 pi. So if we've traveled a whole 2 pi here, right, we're now going to go over in another rotation. So keep in mind with this little sliver, so if I were to then add this little 90 degrees, so we can have now over a 90-degree angle. So 2 pi plus pi over 2. So 2 pi plus pi over 2 amount, and it's adding because we are talking about this counterclockwise motion. So 4 pi over 2 plus pi over 2 is equal to 5 pi over 2. So this right here is 5 pi over 2, meaning that we now need to take an additional little sliver. Now this little sliver right here, we're going to use a reference angle. Now keep in mind your reference angle is referring to what we know from your first quadrant. And it's always from this terminal ray to the x-axis. So one more time, it looks like this ray is cutting your 90-degree angle in half, which meaning from your first quadrant, that would be pi over 4. Right, pi over 4 is between 0 and pi over 2. We just cut this one in half. Meaning if this is pi over 4 amount, that also means that this one is pi over 4. So we can add an additional pi over 4 onto this 5 pi over 2. So we can get a common denominator. So 10 pi over 2 plus pi over 4. Sorry, 10 pi over, oh no. That would make 11 pi over 4. So this whole thing should be 11 pi over 4 amount. Now there is another way to approach this as well. So let me get rid of that. We'll get rid of all of this. Okay, so we just talked about this being 0 and this being this 2 pi amount. And we were talking about as well this reference angle that we have shared from before, so pi over 4, which matches, again, this pi over 4 here. Now, in this case, right, we are between these angles. So if we're using something kind of easy like 0, this one would have been pi. This is 2 pi. That means that this next one, if we did another full rotation, would be 3 pi and then 4 pi. And we could keep going around your unit circle. But notice how we haven't got to this 3 pi. But if we understand that this is actually in pi's over 4, what we can do is put everything in terms of pi over 4, meaning that this pi could be 4 pi over 4. So there's, at this point in its unit circle, is 4 slices of pi's over 4, or no slices of pi's over 4, or 1 slice of pi over 4, or 2 slices of pi over 4, right? And we can keep going. So for us, right, if we rewrite this 3 pi into 12 pi over 4, right, notice that we didn't fully quite achieve this 3 pi, or 12 pi over 4. Instead, we went 1 backwards. And as over here as well, right, if this was 10 pi over 4, which means it's now 5 pi over 2, right? So this is the real angle of 5 pi over 2, or just take that away, just pi over 2, right? We're between 12 pi over 4 and 10 pi over 4, which means your angle here must be the in-between number, 11 pi over 4. If it was down here, right, it would be 1 more than 12, making this 13 pi over 4. So that's just another way to kind of visualize some of these values. Let's try it again with number 7. Now, number 7, we are working in the the clockwise motion. So we do have a negative angle here. So we're just going to put a negative sign in our answer. And you'll notice here that this time we're not bisecting that angle in half. Instead, though, it does allow us to see that half of your radius, right? If your radius is always 1, we now have half of that. Half of that is going to be from your height. So your x value here is your height, or sorry, your x value here is half, meaning that across from this half is a 30-degree angle. And if we have this 90-degree angle, that means that this angle here is 60 degrees. Therefore, as a radian measure, it should be pi over 3. So we can use what we know about a special right triangle, right? 30, 60, 90, on a unit circle. That would be, well, I guess it should be 1 root 3 and 2, right? It just means that this 30 degrees is half of the 90-degree angle. So, and this is where that half is coming from. So if we can understand that this is now pi over 3, so again, using your reference angle, if this is pi over 3 from this angle right here, so if that's pi over 3 as the reference angle, that just means when we travel around your unit circle, right, we're missing by a sliver of pi over 3. So we can say 2 pi minus this pi over 3 to then get, well, actually, we want to change your units, right? 6 pi over 3 minus pi over 3 to make 5 pi over 3. And again, the direction is negative. Therefore, we should have a negative 5 pi over 3. We could also think about it differently as well, that if we've traveled, right, half, and we kind of cut a little bit, right? If we've traveled half of your unit circle, this would be pi. We traveled then another 90 degrees, so pi over 2. And now we need to add just this little tiny sliver here. I'll put this in a different color. If we can understand that this is pi over 3, that must mean that this is pi over 6, in which case we can add all of these values up, going that these are from these negative direction. Now, when we add negative pi minus pi over 2 minus pi over 6, having them all have a common denominator of 6, we should get the following. So let's see, we get negative 10 pi over 6, which can reduce to negative 5 pi over 3, which is exactly what we got over here as well. So we can start to cut from what we know. What we do have to rely on is understanding your special right triangles and how they might serve our purpose in helping us with the following. So hopefully you found that video informative. Again, here's the answer key. Anytime you go over like a full revolution, that is going to be considered a 2 pi amount. And then we have to just keep traveling. So again, over here, if we were to do it again, which if I am just to do a quick one over here, like 6, we are traveling around in this clockwise motion, right? So we will have a negative angle. So we have 0, we have 2 pi, we now have another 90-degree angle, so pi over 2. And these are all negatives here. So now we need to figure out, okay, well, this little sliver, well, what would we add? So that makes us look at this bigger picture. So again, this being half means that directly across from that half amount is 30, which means that the degree here must be 60. So we're at, again, our reference angle of pi over 3. So that must mean that this is pi over 3 to make this as pi over 6. So therefore, we can subtract all of these, negative 2 pi minus pi over 2 minus pi over 6, get a common denominator. So that would be everything to have 6 on the bottom. So we get negative 12 pi minus 3 pi minus pi all over 6. So let's see, 12 and 3, that's 15, that's 16 pi over 6. And that's all negative, so we can reduce. They both have at least a 2 in it. So negative 8 pi over 3. All right, that should be it. Please keep watching some of your videos to get more comfortable. There's lots out there for how to find and evaluate your trig functions, how to find reference angles, and so forth.